continuing in the pandas only, right? Remember? Okay, so we were plotting the graphs. Okay, as you guys remember what I told you, that if we have the graphs which are very complex in nature, then we take the help of C1. So what all graphs we have covered up till now? We have seen categorical features only, right? Categorical univariate. We are yet to cover categorical bivariate, numerical univariate, and numerical bivariate. Okay, so let's get back to the point. Let me create the table once again for the C1, where when we are having the univariate data and bivariate data, we are having numerical feature and categorical feature. Univariate numeric, distribution plot we have. Bivariate numerical, we are having pair plot and joint plot. Now for categorical, we have already seen that we create cat plot. Here also we are going to create cat plot, but the kind is going to be different. You remember in the, what we can say, in the command of the cat plot, there is a one parameter called as kind, right? So that kind is going to be different when we are talking about the bivariate categorical. Let me clear all the joins, and now we are going to talk about, let's say, univariate numerical type of data. Okay. Simply writing it down. Let's say heading. Univariate numerical data. Okay. Since what I told you, whenever we are having univariate type of data, which means we are picking only one column at a time. Now this column is numerical in nature this time. So what are plots? So guys, remember, we do have some of the plots specifically for this condition. Let's say KDE and histogram, right? Now we will see how we can create this KDE and histogram with the help of C1. You will see there is going to be a huge difference to the plot which we created in the pandas and right now creating here in the C1. Okay, so simply I'm writing it down. SNS dot dist plot. Okay, if you guys remember what I told you, that whenever we are having univariate numerical type of data, it is going to be distribution plot, right? So for that, I am just picking one column of numerical type. For that, I am writing D types. Here I am picking loan amount as my numerical feature. DF1 of loan amount. Okay, we are going to plot the distribution plot for this. Since distribution plot, it is plot in itself, so we don't need to mention any other parameter in this. I'm going to run this. You will see it is giving me a plot like this. Now understand some of the things. You can see there is something called as grid getting created in the pattern. So what do we call this lines or let's say square boxes as? These are called as grids. Grid means what? Whenever you plot the graph, if you guys remember in your school days, there is something called as the graph paper, right? In that graph paper, there is always the kind of boxes you will see that will help you to create the scale in your data and also help you to mark the accurate points, right? So these are the grids. Whenever the data is numerical in nature, we will always see that grid is getting created in the backend. What is the reason behind that? To point the data with that accuracy, to point the coordinate with that accuracy. Okay. Now here you can see we are creating two graphs together. This one is your histogram, right? And this one is your KDE. So suppose I want only one graph to be created. I don't want both of them to be created all at once. Okay. Because for the histogram, we do have other, let's say, method in the C1. I want only KDE to appear. So for that purpose, you can simply mention it down here. Let's say putting one comma. Kind is equals to or let's say KDE is equals to false. Write it down, false like this. Okay, running it, you will see now it is showing histogram only. Okay, since if you want KDE to appear, you have to write hist is equals to false here. If you want your histogram to appear, you are going to write KDE is equals to false. So since I'm writing histogram is equals to false, you can see it is creating the graph like this. Okay. Now, if you guys remember, it is giving me the x-axis as loan amount, whereas y-axis is nothing but the density. What density? Probability density function. Once you go in the stat section, you will understand what is this probability density function is. Okay. Now, one more thing, you can see the graph is looking very small. Now, if you want to enhance the size of the graph, if you guys remember previously, we enhanced the size of the graph with the help of Matplotlib, right? We are going to do the same here. And what I told you, whenever you want to enhance the size of the graph, you have to mention the plot size within the same cell of the graph where you are writing the command, right? Which means if you are creating the graph or writing the command of the graph in this cell, you have to mention the plotting or let's say enhancing size command here in the same cell. Then only it is going to work. If you have written the command here and now you are plotting the graph here, Python will not be able to understand to which graph you want to enhance the size of. Okay, so simply mention plt.figure here. Plt.figure is the method that helps you to enhance the size of the graph. Okay. Always remember, SNS is for creation of complex graphs, whereas Matplotlib is for the beautification purpose of the graph. Okay. Now, plt.figure, you want to enhance the size of the graph, so you have to mention one parameter, which is figure size. Inside that, you have to mention 10, 7. Whatever. 10 means, what is the first parameter here? It is signifying your length. What is the next one? Your breadth. So whatever the length or breadth you want to give, you can, depending upon your choice. Now you can see how huge the graph is looking. Very clear as well. I can judge. Okay. Also, you can see this graph is skewed, which means disturbed in nature, right? We do have outliers. That's why we can see the tail in the graph. Okay. So that's how you can create KDE here. Let me show you the command. And always remember, you cannot enhance the size of every graph. Or you can say every next graph. No, it completely depends on what. I will show you. Okay. Right now, you can see there is no grid thing mentioned here. But it is creating a grid. No problem. You will see there is something mentioned here like grid axis. For that particular graphs, you cannot enhance the size. Okay. So as long as you cannot see any grid axis thing here written, just understand one thing, you can enhance the size of the graph with the help of Matplotlib. Okay. Is this clear? Okay. Let's move forward. Let's talk about histogram. How we can plot histogram. So previously you guys have seen when we were plotting histogram with the help of dist plot, it was not looking that good, right? So I'm going to create the histogram here, simply writing sns.histplot. Inside that, I'm again mentioning the same column. If you want, you can pick any other numerical feature, no problem. Once you are done writing this df of loan amount into the histplot, simply run this. You can see it is looking like a beautiful histogram. Now, what you can do again is increasing the size of the graph. I'm just copying the statement of Matplotlib from here, pasting it down right here. Now, what will happen? If you want to enhance the size of the graph, I am keeping the length as 11 and breadth as 5. You can see how clear the histogram is looking. The proper bars, and you can also judge the frequency, the count, everything. Okay. Now again, I'm telling you guys, if you want to change the color or whatever, the same way you can do with the help of palettes. If you guys remember the palette thing here, which we were talking about, right? So if you want to check if we have the palette option here in the hist plot, we can simply mention help and inside sns.histplot. Okay. Now I can see X, Y, Y, weights, none, stats count, wins auto. What is the stat count? It is talking about what this histogram is actually doing. Counting, right? Frequency. Okay. And can you see something called as palettes here? You can see palette is equals to none. Okay. If you guys remember, previously when we were talking about the palette in this section, let's say in the palette section of the cat plot. There is the palettes here. Okay, same thing, which means we can change the palette. Okay, let's coming back here. I'm just simply mentioning, let's say palette equals to blues. Okay, let's see. I'm writing some spelling here. Let me check. Oh, my bad. Double L. Palette. It's copy done from here. Every time I commit this mistake. Palettes. Create generator. PDE. Refresh. Next to palette. Okay. So see, blues is the by default one. If you want, you can change it to purples as well. Okay, it's not picking out. Let's pick a similar one from, blues. Okay. Picking the default color. Let's pick something. See, if I'm even changing the color, still it is not working. So palette section is not available for this graph. Okay. We can do the hit and trial method. Even if I'm mentioning something, still it is not working the same way. See, by default color is blue. So that's what I told you. Not every graph we can enhance the size of. Not every graph we can change the color of. Okay. Yes, going to talk about. Since you guys have seen, we are done with the univariate numerical type of data. Okay. Now we will talk about bivariate, categorical or numerical type of data. Okay, so I'm just giving the heading here. Bivariate numerical. Now there are some things to understand in these graphs. Okay. Bivariate numerical data. Okay. Bivariate means what? We are going to pick two columns at a time, two features at a time. Okay. And in this section, we can create two types of graph. Let's say joint plot and pair plot. Okay. So first of all, let's talk about the joint plot. Simply, I'm writing sns.joint plot. We need to remember that we have to give both x-axis and y-axis now. Mentioning data is equals to df1. X-axis as, let's say, co-applicant income. Y-axis as loan amount. Okay. Now we have to mention kind. So whenever we are having two features coming into the picture, do you remember, have we created any sort of graph like this before? Where two numerical columns we were taking as the parameters and was pressure. Put some pressure in your brain. Heat map, right? Correlation, correct. So, correlation is one type of graph, and here we are creating another type of graph, which is scatter plot. Okay? Because we know that whenever we want to find the correlation, it is very easy. We can simply write this SNS.heatmap, df.corr for the correlation. What about the other graphs? So whenever we are talking about joint plot, joint means what? It is going to give me the coordinates of both the features by putting one dot there. And that dot is called as scatter. If I'm going to create the graph of this, you will see this is talking about the scatter. Okay. Now, if you look into this very carefully, what it is doing, you are having your x-axis here, you are having y-axis here. What is this, guys? What it is trying to create here is creating univariate analysis of co-applicant income with the help of histogram. This is creating univariate analysis of the loan amount with the help of histogram. Okay. Now, the coordinates of these 2 points, where are they matching? Okay. So, this is the graph telling me that. Also, you can see we are again having the grids. Now, focus on one point. Previously, when we were creating the graphs like histogram, this one, here can you see something called as axis grid? No. We were clearly increasing the size of graph in this case. But here in this case, even if I try to enhance the size of the graph, that is not going to work. If you want, you can change the numbers, you can try it. You will see it is going to create a constant graph for you. Why? Because of this axis grid thing. Now, what is this axis grid thing? What I told you, whenever we were in school, you guys must be having the graph paper, and that helps you to point the accurate coordinate, right? This is the same axis grid here. The axis grid helps you to point the accurate coordinates of two numerical features. If I'm going to enhance the size of the graph or reduce the size of the graph, what is going to happen? My coordinates, there is a possibility that they lose their place in the case of scale or legend, right? That's why it is not allowed to increase the size of the scatter plot. This is what we call it as scatter plot. Now, how to read the scatter plot? Whenever we talk about the scatter plot, can we say that we are having co-applicant income like this? Okay. We are having loan amount like this. There is, let's say, there is one customer whose co-applicant income is 0, but that person is asking for the loan amount 700 rupees something. Okay. Co-applicant income is what? The nominee income, right? If you want me to change this particular feature, let's try with the applicant income. Right now, it's not giving me that much great. Yeah. Now here you can see, I can now read this graph very easily. Can I say that the applicant income of a person is 80K something, and he is asking for the loan amount of 350 rupees something plus, okay? Now there is a thing. Can we judge that person got the loan or not? So we have very interesting feature here called as, not feature, you can say that, parameter called as who. Who is something that will help you to judge the coordinate. If this, I'm picking the loan status. As you can see, it is the categorical feature. Pasting it down right here, running it. You can see. Now, it's the same thing. 80,000, 80K, let's say, applicant income asking for 350 plus rupee loan. Is he getting the loan? No. So, Hui helps me to read the coordinates. Getting it? Previously, that was just, those were just the points scattered around the grids. But now, Hui helps me to extract some meaning from those points. And what is this? This is nothing but your legend. This legend is nothing but the scale for the Hui. It is telling you that blue dots are for yes and orange dots are for no. Now you must be asking the question, can we only plot V for the loan status? No. You can pick up any categorical features from here. It shouldn't be numerical one. I'm telling you on the first hand that you should not pick numerical features here in this case. Coming here, you can see, along with the discrete values present inside the feature, it is going to change the color of the dots. For 0, we are having blue now, 1 for orange, 2 for green, and 3 plus for red. So you can get the better idea. Here you can see that 80K applicant income person asking for 350 plus of loan amount have 3 plus dependents. Okay. So that is how you can rate the scatter plot. Usually scatter plot helps us to judge the points which are going out of the range. What we call those points as? The points which are not falling under the category where most of the points are falling. What we call such points as outliers. Okay. So it helps us to give the better understanding of outliers. Okay. Look into this. If you have any sort of question, you can ask me. In my notebook, grids are not visible. Okay. Wait for a minute. This is your plot. They have written the same command as that of mine. Guys, what I can suggest you is to pip install your C1 again. Maybe some, what we can say, updates are there. That's why the grids are not available. But you can see something written like this, axis grid, joint grid. Is this part visible for you? It is written. Okay. So let me check the help section. Have they introduced something called as grid? Grid is equals to yes is also one parameter present. So let me check it. SMS to example in the help section. Joint plot. X, Y, data kind scatter, color none, height 6, space, drop NA, joint, imaginary, palette. No guys, we don't have any option of the grid. It should show the grid by default. Okay, do one thing. Try to do pip install C1 once again. Let me show you the command. And then try it. Pip install C1. Okay. Then do import C1 as SMS. Okay. There is a possibility that could be different in mine than yours because of the updates. If you guys have not updated your Jupyter or mine is not updated, I'm not sure because mine is updated. Okay, so you can update and check. I'm copying the code and pasting it down in your chat box so that you guys can pick it from here. Okay. Once scatter is done, now you understand why do we create scatter for? The scatter we create is because we have two numerical features and I want to get the insight from those two numerical features, right? Okay, understood. And what is the next thing? What if I want to plot the scatter for every numerical feature combination in my data set? That is going to be hard work, right? Manual task. Going to take a lot of your effort. You don't want that. So in that case, they introduce something called as pair plot. Now this pair plot will help you SNS.pairplot. Inside the pair plot, you just need to mention your data set. Okay. I am mentioning my data is equals to df1. Simple, your job is done. Running it. It's going to take a minute or so because it is plotting the combination of every numerical feature along with the every next numerical feature. Kind of a matrix structure. Okay. You can see you are having the grids here. Maybe this is not going to show grid again in your plot. Maybe there is a possibility. If it is not showing for the previous one, there is a possibility it is not going to show the grid for this one as well. Okay. Now you can see we are having the scatter plot of every combination of numerical feature present inside my data set. Okay. Now if you want, you can also declare tree here. Let's say loan status. Yes. Okay. So now you can see it is giving me the pair plot like this. Now you will ask me, what is the purpose? Why do we plot such graph? To check the linearity among numerical features. You guys remember what do we do? When we talk about correlation, whenever there is a straight line between two numerical features, we say that the data is correlated, right? Likewise, once you go into or hop into the machine learning module, you will see that identifying the linearity in the data is very important for the models like linear regression and the logistic regression. Okay, regression type of models, I can say. So in that case, you cannot pick up the combination of two different numerical features every time and plot the graph of it. Instead, you are going to directly declare a pair plot that will help you to plot the graph of every two features present in your data set. That is numerical in nature. Okay, not categorical one. If you want, you can also declare the whole in this particular pair plot. So whenever you want to declare or plot one scatter plot, you're going to choose joint plot. Whenever you want the scatter plot for every feature present inside your data, you're going to choose pair plot. Okay. Okay, let's move forward to the last plot of Seaborn, which is scat plot. Okay, which means bivariate categorical type of data. Let me write it down. Okay, so whenever we talk about bivariate categorical type of data, it means, I told you, if you guys remember, I clearly mentioned previously that whenever you are having two categorical features, you cannot directly plot the graph of it, right? There must be some numerical features, or else you can convert your categorical feature into the number. Then only you can create the graph on the basis of this bivariate categorical. Yeah, so basically what happened, why do we create pair plot? Is to check the linearity in the data. When I'm talking about linearity, if two of the numerical features are linear in nature, what I told you, you will understand the significance of this in the machine learning. Whenever two of the features are linear in nature, when I'm talking about linear, that should not be a very straight line. No, there should be data points like this, which is showing kind of a linearity in the data. Okay, so that helps us to judge that there is some linearity present inside the data set. Maybe correlation. sort of correlation. Also, there are some of the models which completely works on the linear data. Let's say your linear regression and logistic regression model. Okay. So in that case, you must be needing this knowledge. Okay. Chalo, get back to the point. We were talking about bivariate categorical. We cannot directly plot the graphs of the categorical feature. We need to convert at least one into the numerical one, right? So for that, I'm just simply writing SNS.catplot, picking up data as DF, which is the name of my data. X-axis, let's say gender. Y-axis, any numerical feature. Going back into the D types, picking up one numerical feature from here, let's say applicant income. Going back down, pasting it in the Y. Now, what is the kind of plot we can create here? Box plot. Okay, running it. You can see it is giving me a box plot like this. Again, this is axis grid, phase grid, so we cannot enhance the size of the graph. What we can do is, we can't do anything. Let's try to pick this as loan status. Okay. So if you see the box plot, you will see it is coming here, right? And it is considering every value for the known status yes and no after 10,000 as the outlier. Okay. This sometimes changes. Let's say if I declare gender here, it is going to plot the box according to the gender. Now you can see for male, the outlier is coming above 10K and for female, it is coming above 8K somewhere. Okay. And my outlier is ending till 20K. But in the case of male, it is ending and going up till 80K. So it gives me such type of understanding. Guys, why do we create graph? What do you think? If you are performing a data analysis or if you are becoming data analyst or scientist, what is the reason of creating graph? Chalo. Analysis is the one purpose. I understand. That too we are doing since day one. What are the other reasons? What do you guys think? Presentation. Okay. So reading graph should be very important because you have to present your data every now and then. You have to justify what you are doing. You just can't randomly move the data from here and there and make random predictions on it. You have to justify what you have done with your data set by the representation of it. And yes, it is correct. It is very easy to interpret the trends here with the help of the graph. You can see, I can make few of these statements just by looking into the graphs. Okay. Yes. And that is also one correct statement to share the data with team and stakeholders in a more understandable manner. Okay. Because they are not your technical people. They are not going to understand what you have written here. SNS.catplot. No. They just want the visual representation and you presenting it to them to make them understand what are the patterns, what are the things. Simple. Okay, they don't want to put pressure in their head. That's why they hired you. Simple. Okay, so your graph should be, of course, appealing, but their representation should be very clear as well. Here you can see the box plot is coming very compressed. Okay, yes, we do have option of creating box plot in. We do have option of creating box plot in Plotly PyGal as well. There you will see it kind of look way more appealing, enhanced, and visually representative as well. If you hover the mouse into the graph, it will give you the numbers or representation of that particular graph. Okay, so Plotly PyGal, it is nothing but the enhanced version of this Seaborn and Matplotlib. But the scatter plots and kind of plots like this, we usually create with the help of Seaborn because that is better choice. Okay. Yeah, Pathan was hit, correct. Which one? Which one? Which one you want the demonstration of? This one you are talking about? Air plot? Plotly and parallel you're talking about, right? Yeah. We are going to cover that tomorrow, not today. Okay. Today we are covering Seaborn. Once we are done with the Seaborn, then we will hop into plotly and parallel. Guys, let me zoom in this report. Yeah, this is the correct slide, I guess. Now, what is the next thing we are going to do? Once your the plot is plotted, let me show you. What I told you, this box plot is looking kind of compressed, right? You can represent this data with a different kind as well. Let's say we do have something called as swarm plot. Okay, running it. Now you can see that it is representing your data in a swarm manner. It is nothing but same as that of the box plot, but it is representing your data in the swarm manner. In the box plot, you can clearly identify what all outliers do we have, but here it is going to cause a bit difficulty for you. Now, if you want, you can see the dots are coming into the picture. If you want to represent them with the help of TUI, you can do that as well. Let's say simply write loan status. So every data which is getting represented with the dots or let's say scatter, we can represent them with the help of TUI as well. Okay. And TUI should always be your categorical feature. Now here you can see, easy to understand. Can I say that applicant income 80,000 rupees with the gender male is not getting the loan and that person is acting as outlier as well? Okay. So you can make this much of insight just by looking into a graph. Okay. Similarly, okay, I'll come back to the point. Okay. So, Shreya, what you are, Sonu, what you are talking about, you have not seen Plotly or Pygal? You guys have not covered it? Okay, no problem. You can cover it here. Chalo. So, cat plot we are done. Swarm plot we have also done. Yeah. So, we were talking about swarm. Let's pick this up. There is one more plot called as violin. Okay. Now you will see it is creating a violin just because I have declared V as loan status, it is creating this separate violins, okay, for male and for female. Okay. Now, do you guys understand one thing? That box plot was the perfect representation for the outliers. These are just the fancy things. I cannot even judge which of the entries are acting as outlier. Can I judge that? Yeah. I am to getting the idea that from this point, from to this point, this is whole the tail and we are having entries between them, which is not true. These are the fancy things, guys. We need to be very particular about the graphs which we are choosing. So we declare such type of graph just to make it look bit good, but most of the time we choose this and this type of graphs. Okay. And why the elimination of this graph is happening? Because I am unable to identify where the median is coming, what is the maximum point, what is the minimum point of this box. Okay. So it is just for good for the outlier data, and this is good to show the outliers. Okay. UI looks good here, not here. So every graph has its own advantage and disadvantages. And here we are done with your Seaborn. So if you have any sort of question, you can ask me because later after 5 minutes of break, we'll be hopping into the Matplotlib. Okay. Okay, let's talk about Matplotlib, okay? Creating one new file. Don't worry, we'll cover some of the graphs, not too much. Now Matplotlib. As I told you, this is the library which helps us for the visualization as well as the beautification of the graph. Whenever you want to enhance the size, change the color, mention the labels, give the title to your graph, all of these are possible with the help of Matplotlib. So let me import the library first. Simply you have to write import matplotlib dot pyplot as plt. Okay, so this is the command which we give for importing Matplotlib. It is a bit different from the previous command. Okay, so when you import Matplotlib, after that you can use it. I don't have the proper data for the Matplotlib, but if you guys remember, we work with the data set of date time, right? So once we are done with the Matplotlib here, we can go back to the data set and we can plot some of the graphs in that particular data. Okay, so right now I'm also importing the NumPy. First of all, we will see how we can create the graphs here, and later we can implement it on the data set. Okay, so first graph which we are going to talk about is the line plot. Very popular, most frequently used. Okay, so for the line graph, I am first declaring some of the, let's say, coordinates 5, 2, 7, 9. Y, some of the coordinates. What is the data type, guys? Do you remember what is this data type? So how we can simply create the line graph? Creating graph in the Matplotlib is very easy. You just need to simply write plt.line for the line graph. Matplotlib as plt, we are simply writing plt.line for the line graph. We just need to mention the x-axis. For us, x-axis is x and y-axis is y. Simple. That's why I'm simply writing x comma y and plotting it. Plt.plot, my bad. Plt.line, it's there. Okay, groups are different. Okay, just to go one more save. Yeah. So you can see we are having a line graph like this. Okay. Let me change this. Yeah, now it is better. So you can see we are having the line graphs like this. But you can see what I told you. The graphs which we create with the help of Matplotlib does not have any name. Getting it? We don't have x-axis here. We don't have a y-axis label here. We don't have the name of the graph here. What it is talking about. What stats this graph is giving me. All of these things are not available here. We have to manually create it. First, I am talking about labeling my x-axis and y-axis. Okay. Simply you have to write plt.xlabel. Guys, this should be in the same cell. Okay. I am writing profit. plt.ylabel. That will give you the label of y-axis. Let's say sales. Okay. Running it. You can see we are having profit coming here, sales coming here. Okay. Now, if you want to give the heading to the graph, you can simply write plt.label and let's say sales analysis. multi.title. My bad. Okay, you can see now we are having the name of the graph, the X label and the Y label. What else you can do with this line graph? You can put the dots where the coordinates are matching. Okay, that is also possible. Just wait for a minute. PLT dot plot. Okay, it's not in here. You have to mention directly here. Scatter equals to 2. Dots is equals to 2. Wait a minute, let me check. Give me a moment, okay? Marker should be there. Marker is equals to A. Yeah. Okay. So you can see now it is marking the coordinates for you as well. So wherever the coordinates are matching, it is giving you the marker for that position. If you want, you can change the marker of your own choice. Let's say if you want asterisks to be there, you can simply draw the asterisk. You want something else to be there. Okay, now it's 0. Special character. Let's say dollar, hash, whatever you want. You can plot that. Or maybe, yeah. Okay. So let's say a string, whatever that helps us to point the coordinates, you can choose as the marker. Okay. Now there is a possibility that you can also change the color of your marker as well. Okay. That we will see. Okay. So suppose if you have declared x-axis and you have also declared y-axis, now you have declared the marker, you want to change the color of the line. Okay. So for that case, you can simply mention our name, let's say O colon R. Let's remove the marker from here. Too many things to remember, right? Yeah. So this O is representing the marker. This R is representing the color. Likewise, what I told you, you can create, or let's say the color code for every graph is different. Okay. So here the R represents red color. If you write G, it is going to represent green color. If you write K, it is going to represent the black color. Okay. So like this, again, I am telling you, you have to search this. Okay, you cannot remember the color codes. First place is for marker, second place is for color code. Okay. Also, it is helping you to create the dotted lines. You can see that. So, how is the format? Simple. It is very simple. You have to first write the marker. The same way we have written, like O. Now you have to mention the type of line. Let's say if you want dashed line, so you can mention dash. And then you can mention the color code. So it goes hand in hand, like this. By default, if you don't mention anything, it is going to pick up the dot. Okay. Suppose we want dashed line to be there. I'm going to mention dashed line. Okay. C So, one comment. Let's say we will change this to the FMT. There's a dates I'm telling you. Wait a minute. Away from here. Okay. If I that here, it. Okay. So yeah, what all representation you can do is the dot. By default, this is dot. For the dash line, you can give dash like this. You can see. And for the color, you have to mention the color like this. Okay. So what I told you, first marker, then the type of line which you want, and then the color. Okay. So we are having 4 options: the solid line, the dotted, the dashed one, and the dash dotted line. Let's say dash and dotted line, kind of this. Okay. So you can create all these type of modifications in your line. Now, if you want to do modification in your marker, you can also increase the size of the marker. You can change the color of the marker. All of these things are possible. Okay. It's very simple. You just need to mention marker color as NEC, and that color, let's say if you want blue there, you can simply mention blue. So you can see the color of the marker is changing into blue. If you want green, you can mention green. Let's say red. That will be usually different, like this. Okay. So these all things you can do. First one is for the line, and second one, MEC, is for the color of marker. Okay. So this is all about your line graph. Okay, if you want to increase the figure size, that is also possible. Simply write plt dot figure. Inside that, figure size, FIG size equals to 10,5. Okay, wait a minute. I have to plot this here. I have to mention the figure size here. PLT to figure, FIG size equals to 10,5. Okay, so you can enhance the size of the graph. Okay, so always enhance the size before plotting it. You can see I'm enhancing, then plotting it, then labeling it, then doing whatever I want. Okay, so it is possible you can enhance the figure size as well. Now, the second type of graph. I'm not going through bar plot and histogram, guys. You guys have already covered it. Okay? If you want, you can go through the notes. It is very easy. plt.bar for bar plot, plt.hist for histogram. I'm picking up those which are actually going to create ruckus in your head. So let's say I'm picking up the stacked plots. Okay, that is something new. You guys have not seen yet. So let's discuss about the stacked plots. What are these? Okay. The stacked plots are most frequently used when you will do the analysis or you read the analysis. Okay. Let me write it down. Stacked plots. I'm creating two, let's say, arrays. First, I'm creating one list, or let's say x underscore 1 as A, comma B, comma C, comma D. Okay. Now I'm creating y1 as some numbers. Let's say 10, comma 20, comma 10, comma 30. Y2 as 20, comma 25, 15, 25. Okay. Now I'm going to talk about stacked plots. What I told you, plt.bar is something that will help you to create the bar graph. So I'm mentioning x-axis for my bar, which is one categorical feature. Okay. Y-axis for my bar, which is one numerical feature. Running it. You can see it is creating a bar for me. Very easy. If you want to change the color, you can also change the color. Let's say COLOUR equals to R for red. Okay. COLOR always. Okay. You can see now it is creating a red plot for me. Now what is stacked plot? I'm going to create another plot stacking up with this bar. Okay. How come? I'm simply writing plt.bar. I'm going to keep my x-axis as it is, which is x underscore 1. Now, I'm going to choose my y-axis again, which is y underscore 2. Now, we have to decide which one we want to keep in the bottom, which is y1. Okay. Now, running it, y underscore 1. You can see it is creating a plot for me, getting stacked up. So first we have chosen y1. So it is picking up till 10. What is y2? 20. So it is picking 20 more steps after the 10. That's what we call it as stacked plots. Which means what? It is stacking up with one another. Okay. Now if you want to change the color of the stacked plot, let's say you want to change the color to green, you can simply mention color is equals to G. Okay. If you want to make it black, you can write simply K as the color equals to black, like this. If you want to change the combos, you can change the combos. Okay. So this is what stacked plot looks like. Yeah. Because first is the bar, bottom one, and the second one is helping me to stack up above that bottom one. Okay. Both of the lines you have to write. It's like circle, if you want to create polygons. Okay. All of these, how you can create. It's very simple. You have to simply write plt.circle. Easy, right? Now I will tell you what is the significance of every command which we are giving. You are writing plt.circle. Capital C should be there. Then you have to mention the coordinate 0, 0, which means I want my circle to start from there. Okay. You have to mention the radius of the circle, whatever radius you want. Let's say I am writing 0.5 as the radius. Okay. Now, across which axis you want? Face axis, or let's say the axis which you want. We are writing this as y. Simple. Now, if I'm going to run this, you can see, is it plotting something for me? No. So, another line I'm going to write. plt dot GCA. Running it. You can see, now this is giving me this background. Basically, what is happening? I have to declare the circle, but where to plot the circle, right? That's why I'm mentioning GCA. Now, I'm writing add patch. Which patch? This patch. So, I have to save this in some variable, let's say VAR. And inside the patch, I have to mention that particular variable. Okay, running it, you can see. So basically what happened? 0, 0 was my axis, radius was 0.5, FC was a bar. That's why you can see it is creating a quarter for me. Okay. Now, if you write PLT dot axis, let's say scaled, getting it? That was creating the quarter graph for you, right? Now it is creating a pure circle right in the center of the patch. Okay. Simple. Now, if you ask me, what if I change this FC to X? Okay, you can see what it is showing. Invalid RGBA argument. Okay, so basically, so remember in Matplotlib, whenever you see FC, it is nothing but the face color. Okay, FC means face color. In C1, it is CMap or palette. Okay, and here also color. 2 or 3 words commonly gets used. Okay, so whenever you see color, FC, CMap, and palette, understand that it is talking about the color. Okay, and we have some of the color codes for the Matplotlib like K, G. That helps you to create the shapes like this. Okay.